Once a year, ham radio operators around the world tune their receivers to 17.2 kilohertz and listen for a signal from the west coast of Sweden, transmitted by a 200 kilowatt mechanical alternator built in the early 1920s and still spinning inside a UNESCO World Heritage station. That machine was the work of a Swedish-born engineer named Ernst Alexanderson. He patented the design in 1911, but by the time he was done, that same engineering had helped create RCA, had pioneered television, and had given the Allies a weapon that helped win the Second World War. More than a decade before that alternator existed, Alexanderson was a university student in Sweden with no connection to radio. He was born in 1878 in Uppsala, the son of a classics professor, and he studied engineering at the Royal Institute of Technology in Stockholm before heading to Berlin, where he trained under Adolf Slaby at the Technische Hochschule. Slaby was one of Germany's earliest wireless experimenters, which meant Alexanderson had absorbed the cutting edge of electromagnetic theory before he ever set foot in the United States. He crossed the Atlantic in the early 1900s, worked briefly as a draftsman at an electrical firm in New Jersey, and then joined General Electric in Schenectady, New York, where he caught the attention of Charles Steinmetz, one of the most respected electrical engineers in the country. But Alexanderson wasn't hired to work on radio. He was solving industrial power problems at GE when, in 1904, a Canadian inventor named Reginald Fessenden walked in with a commission that would redirect Alexanderson's entire career. Fessenden wanted to transmit the human voice over radio waves, and the technology of the day couldn't do it. Every radio transmitter in existence relied on spark gaps, which produced bursts of electromagnetic energy that were fine for Morse code but couldn't sustain a continuous audio signal. What Fessenden needed was a machine that generated a smooth, continuous radio frequency wave, and he asked GE to build a high-frequency alternator capable of spinning fast enough to produce one. For a while, it looked like an impossible request. Nobody had built an alternator that could rotate at the speeds needed to generate radio frequency current directly. But Alexanderson took the commission, and over the next 2 years, he engineered a machine that did exactly what Fessenden had asked for. On December 21, 1906, Fessenden used an early Alexanderson alternator at his station in Brant Rock, Massachusetts, for a documented public demonstration of voice radio telephony. It worked. For the first time, a radio transmitter was sending continuous audio across a meaningful distance, not just coded dots and dashes. But Alexanderson wasn't done, not even close. The first alternators operated at around 50 kilowatts. Within a decade, Alexanderson had scaled the design to 200 kilowatts and installed a unit at the U.S. Navy station in New Brunswick, New Jersey, under call sign NFF. In 1918, that station was described as the most powerful radio transmitter on Earth, and it became the primary hub for Allied transatlantic naval communications during the final year of the First World War. Alexanderson's alternator at New Brunswick was carrying wartime signals for an entire military alliance across the Atlantic Ocean. And the same machine that had just helped the Allies win a war was about to give rise to one of the largest media corporations in history. In 1919, the British Marconi Company tried to buy worldwide exclusive rights to the Alexanderson alternator. The United States government saw a serious problem with that arrangement. Handing the most powerful radio technology in existence to a foreign company meant that international wireless communications from American soil would be controlled from London. The U.S. Navy and officials in Washington pushed General Electric to refuse the sale and instead fold the alternator technology into a new American-owned company. That company was the Radio Corporation of America, Alexanderson became its first chief engineer, splitting his time between GE and RCA through the early 1920s, which, looking back, was probably the only career path that made sense for the man who had built the technology RCA was founded to protect. By 1921, RCA had opened Radio Central at Rocky Point on Long Island, running Alexanderson alternators for commercial and diplomatic transatlantic traffic. That same year, Alexanderson was elected president of the Institute of Radio Engineers, having already received its Medal of Honor in 1919, only the second person ever to receive that award. But the alternator's reach wasn't limited to the United States. Between 1922 and 1924, a new long-wave radio station was built near Varberg on the west coast of Sweden, designed to communicate directly with North America. It was called the Grimeton radio station, and it was equipped with a full-scale Alexanderson alternator surrounded by 6 steel antenna towers standing 127 meters tall, the tallest structures in Sweden at the time. In less than 2 decades, Sweden would understand exactly what those towers were worth. When the Second World War severed Sweden's undersea telegraph cables, Grimeton became Sweden's only telecommunications link with the outside world. A machine that had been built for commercial transatlantic traffic was suddenly carrying a neutral nation's entire diplomatic and intelligence communications through the war. And the timing of that is worth sitting with for a moment. The station was built in the early 1920s for peacetime commerce. Nobody designing it was thinking about a scenario where every other communications channel into or out of Sweden would go dark. But when that scenario arrived, the Alexanderson alternator at Grimeton was the one piece of infrastructure that kept Sweden connected. The station originally housed 2 alternators. One was scrapped in 1960. The other was preserved, maintained, and in 2004, UNESCO added the Grimeton radio station to its World Heritage list, citing it as the only surviving example of a major transmitting station based on pre-electronic technology. That surviving alternator is the one amateur radio operators hear every year under call sign SAQ. But the alternator was only one part of what Alexanderson built over his career. In 1927, the first television signal ever received in the United States was picked up at Alexanderson's own home on Adams Road in Schenectady's GE Realty Plot neighborhood, using a mechanical rotating disc receiver he had developed. The following year, on September 11, 1928, GE broadcast The Queen's Messenger from its Schenectady station, the first television drama ever produced, combining sound and picture on roughly 3-inch screens around the city. Alexanderson was the consulting engineer who coordinated the audio and video for that broadcast. And he wasn't finished there. On May 22, 1930, Alexanderson supervised a closed-circuit projection of a live orchestra performance onto a 7-foot screen at Proctor's Theater in Schenectady, the first projected television broadcast shown to a large public audience. In the space of 3 years, he had taken television from a private experiment in his living room to a theatrical experience. If Alexanderson had stopped there, this would already be a remarkable career. But he kept building. In the late 1930s, working with GE colleagues Martin Edwards and Kermit Bowman, he developed the amplidyne, a direct current electromechanical amplifier that allowed a very small control signal to precisely govern a very large motor. It had been designed for industrial automation in steel mills, but during the war it became a critical component of anti-aircraft targeting systems, letting radar operators and gunners slew heavy weapons quickly and accurately enough to track fast-moving aircraft. But there's one story from Alexanderson's life that puts the whole career in personal terms. In 1923, his young son Werner was lured from the family's Schenectady home by two men who had promised the boy a rabbit. Alexanderson, drawing on the very technology he had spent his career building, broadcast a description of his son over the radio airwaves. Stations across the country relayed the appeal, and Werner was found unharmed roughly 3 days later in a cabin near Teresa, New York, hundreds of miles from home. One of the kidnappers was later caught and sentenced to prison. Alexanderson retired from full-time work at GE in 1948, but stayed on as a consultant. And from 1952, he consulted for RCA as well, working on early color television systems. He held over 300 U.S. patents across a career that spanned more than 6 decades, received the Edison Medal in 1944, and was inducted into the National Inventors Hall of Fame. He died on May 14, 1975, in Schenectady, New York, at the age of 97. But the machine he built as a young engineer is still standing at Grimeton. Once a year, volunteers start the alternator, the rotor spins up, and call sign SAQ goes out on 17.2 kilohertz from the same transmitter hall under the same 6 towers that first went live more than 100 years ago. For the ham operators who tune in from around the world, that signal is a direct, physical link to the technology that first put a human voice on the radio.